Now we're going to apply some of the rules that we have learned about calculating the arc length in a circle and do some practice problems so you guys can know how to answer these questions when you get to the assignment. So this first one, A, we're going to take our given degrees, which in this case is 120. So 120 over 360 times 2 pi, and then my radius is 10. So this is pretty simple. We can just stick this in our calculator and calculate it for us. This says express your answer in terms of pi. I know this throws some of you guys off. Typically, I don't care if you guys round. That's not a big deal, but we're going to go ahead and follow what it says here. When we express an answer in terms of pi, that means we just don't multiply pi in there. We just leave it out. So in our calculator, and again, my calculator is a little bit older, so it doesn't have a little fraction function. In the new calculators, you can hit alpha y equals enter. Mine doesn't do that. So we're just going to put parentheses. So we're going to do 120 over 360 times 2 times 10. So I multiply everything except pi. And then we're going to put it in fraction form since we got this decimal. And we get 20 over 3. So our answer is 20 thirds. And then since we did not multiply pi in, we're just going to have pi hang out on the outside. So what may happen if you forget and you multiply pi in? So if we multiply that times pi, we would get 20.94. And so on our answer choices, if we don't see that as one of our answer choices, we can always remember, oh, I just need to divide by pi and then put it back in fraction form like so. One thing to remember, not to remember, but one thing to notice is that this 20.94, it just makes a little more sense to us. That's why typically I allow your answers to be in decimal form. 20.94 inches makes a whole lot more sense than 20 thirds pi inches. However, 20 thirds pi inches is the proper way to leave this because if you look, this is just a decimal and it goes on forever. So this is not an exact number. 20 over 3 times pi is a more exact number. However, it doesn't have as much meaning. Let's do B. So our given degrees on B is 80. So we have 80 over 360 times 2 pi. And then our radius here is 20. And let's talk about what's going on here. So we're just trying to find the arc length, and that's this length right here. We can't exactly take a ruler and go through and measure it and get an exact length, but we can take our circumference, figure out the fraction of our circumference that we're dealing with and multiply it together. So if we divided this up into 360 parts, which we do when we do degrees, we have 80 of those 360. So that's the fraction of the circle that we're dealing with. And then we just multiply it times our circumference. So again, we're going to leave in terms of pi. So I'm going to have 80, whoops, forgot my parentheses, 80 over 360 times 2 times 20. And that gives me, again, a decimal. Let's put that back in fraction form. And I get 80 over 9 pi. This is going to give you a reduced fraction. So 80 over 9, it seems like a really weird number. However, that is the most reduced that fraction will go. And then our last one right here, our given degrees is 120 over 360 times 2 pi. Radius is 20. So again, we're just going to stick this in our calculator. 120 over 360 times 2 times 20. Put that in fraction form. And I get 40 over 3 pi inches. We have one more problem to do. This problem right over here. So this says 2 circular cuts were taken from the rectangular region shown. Determine the perimeter of the shaded region. Do not express your answers in terms of pi. So they actually want a decimal number or a decimal for this answer. So we need to figure out the length of each arc plus the length of the sides. So let's start with the lengths of the sides. That's pretty easy. So since we're doing perimeter, we're doing all about length. So we're going to walk along this side, which is going to be 20. We're going to walk along this, which we need to figure out. Walk along this, which is 20, and then walk along this. So I know I've got two 20s in there. So 20 plus 20 plus something, and that is going to give us our perimeter. So we need to figure out what these parts are right here. So this right here, this is going to be a diameter. And if you remember, a diameter is 180 degrees. So 180 over 360 times 2 pi. And then my radius is going to be 4. This diameter is 8. And I only need half of my diameter. So don't forget that. That's a common mistake that students make. They use the diameter instead of the radius. So that's going to be a 4. I'm going to put this in my calculator. We're not leaving in terms of pi, so I'm going to stick the whole thing in. 180 over 360 times 2 pi 8. And I get 25.1. And then I've got two of those that are going to be the same length. So 25.1, 25.1. And then I just add it all together. 20 plus 20 plus 25.1 plus 25.1. And my perimeter is 90.2. They don't give us units here, so it's just 90.2.